So let's now move on to the more complicated part when it comes to debris. Say that you have everything ready to go. You want this to start at frame 30, going in the direction that we specified with velocity. Well, one thing that people might tell you to do is to go into the .NET and say that you want animated static objects. And if we do that, what we'll end up with is the activation working because we're reading that in at every single frame. As a matter of fact, we can also do that with just static objects. So the active attribute will be read in, and we keyframe that, again, up here at the RBD configure. But it's not going to do what we want it to do with velocity, angular velocity, the force, all the stuff we set up here. And so that's where things are tricky, because then we have to go through this soft solver in here to get kind of fancy in how we do that. So that's what I'm going to show you in this particular video here. Now, one thing I will say is that because we're using Bullet, I find that everything works way better when you create your own custom mesh for collision. So in other words, we want the terrain, right? We could try to bring that in through the .NET and just do a volume sample. So with this terrain, we could, let's say, go over here and create maybe a compound shape. That's going to take forever. If we were trying to do this with an RBD solver, which is Houdini's native solver, then basically that would be a volume-based sampling. Also, it's very heavy, it's very slow to do it that way. So what I'm getting at here is that let's bring in the collision. Let's use this convex decomposition SOP to break it up into a bunch of small pieces. And then we're going to turn that into packed pieces. I'm going to cache this out. We'll read that in through the second input. That gives us these pieces. I also deleted a few over here just to save ourselves some memory. So we have that. It's going into the .NET. Inside the .NET, we have the terrain, and that is where that gets loaded in. So let's go ahead and reset this simulation real quick and get into the nitty-gritty. There's our terrain. We need to create static objects, second context geometry. Now, if we go to the top here, we can see that everything is loading in properly. Don't go any further if you don't see things loading in properly. It means that there's something wrong with the mesh, there's something wrong with the name attributes, and you need to resolve that before you move forward. So I just want to point that out. All right, so again, we're reading in this active attribute for our pieces. They're a little tricky to see, so for the terrain, I'm going to turn off the display geometry. And just to show you that everything is working, here is the guide geometry. And actually, I'm glad I did that because it looks like there's something weird with our guide geometry. If we have our collision padding right here, set that to a really low value, 0.001, something like that, and that ought to fix those issues. But do watch out for that. So I'm glad that I double checked right there. If we turn this even lower, maybe actually 0.00025, then that will probably fix some of these holes. But anyway, this is good enough for right now. Okay, like I said, we go forward to frame 30. What do we get? Well, first of all, you'll notice that this scaled very strangely. And this is due to something that's new to Houdini 19. Because if we source in the scale or the p-scale attributes, that is going to naturally affect the collision meshes on its creation frame. So this is actually taking the scale and p-scale and doing another transformation on these guys. We don't want that though. And all we need to do is get rid of scale and p-scale. So we have p-scale and scale, and that will fix the issue. So we go forward, frame 30. We do have activation. However, some of these guys fall straight through, so that's not ideal. And we also don't have velocity occurring at all. So there's a lot to be loved about this situation. Now, what that means is that we need to somehow inject our simulation with velocity and with force on frame 30. So if we go here to the SOP solver, that's what I'm trying to do here. I'm trying to bring in the attributes that I'm reading from our original mesh. If we take a look at where this is going, that is going to our out SimGeo down here. So I want to read in our original attributes, and that is going to be from number 3. So let's go ahead and just go through this line by line. The basic logic here is that if our current frame is equal to our start frame, then go ahead and add in the velocity, the force, and the angular velocity. So what we have up here is, first of all, defining the current frame. For this, I have a channel integer called current frame. We scroll down, that is $F. So that's how we get that piece of data. If that is equal to our start frame, where are we getting our start frame? Well, that's actually being carried in by our pieces. We middle mouse, we have start frame right here. We recorded that start frame all the way up here. Remember when I said that I'd get back to this? Well, here it is, start frame, 30. So if the current frame is equal to that, then go ahead and add velocity. And so we have our velocity multiply right here, and that is just a constant multiplication against velocity. And so I do that for the force and I do that for velocity. This is here to help me control how much of the velocity is going to happen on these rocks. Like I said, velocity ended up being kind of something that I defined like 10 times. Not the cleanest way of doing it, but I'm sure you can do better. We have that. I mean, that's pretty much it. Velocity plus equals, we use the point function. We say, hey, look through our third input, that's index number 2. Look for a special little attribute called velocity and match it up with your point number. Again, these are packed pieces, so we just use point attributes to define everything. That's why we can use point number. That multiplies against the velocity multiplication. Same thing happens for the force, and same thing happens for the angular velocity. So that's all I'm doing right there. It might look a little fancy, but it's really not that bad. Okay, so once we have that, what will our pieces do now? And now our pieces go kaboom. Easy as that. Do keep in mind that I also have a pop speed limit that helps the tiny little pieces of debris from getting too aggressive. We have pop drag spin, and a pop kill if these guys enter into the box. And that's really just about it for this basic ground explosion right here. After we have that, let's import these guys as points. So create points to represent objects. I'm using rocks as the object mask. Same thing as what we have here, rocks. And that gets cached out. Once we cache this out, we have points. Those points are flying around frame 30. We're going to then retime those points. That will allow you to change the timing if you want. But more importantly, it gives us the in-between frames. So that works there, and that's important for motion blur. We then use the transform pieces to bring in those rocks. Be sure to merge in for the area that we define name at. So I have this attribute delete because that's right after we defined name. That then puts on the rocks to the points again, and we will delete anything by an expression. So if we say delete by expression, $F is less than 30 on points, that will prevent anything from showing up before frame 30. Once we have a play blast of this, we end up with something like this. And these guys might be going out a little bit too far right now, but it will add a lot to your simulation. So one thing you can do is you can have a few layers of this. So all you do is change the seed on the pyroburst source, and then you make another version of this. You can layer that on top of this. You can do that as many times as you want until you have enough debris for your situation. I'm going to probably dial in a few more settings, probably chill out the velocity on these guys, just kind of fine tune everything. Again, that takes time, so I don't want to bother you guys with the back and forth there. But that will give you an overall idea of how to add in debris. However, we're not totally done here, because I think it's also important to know how to advect smoke with this debris if you need to. Right now, we're not affecting the main simulation at all. You might want to do that. Sometimes it's nice to have debris kind of spit out of the bottom here. We've seen that in reference a few times. And so I do want to talk about the workflow for advecting smoke if you'd like to. And on top of that, it would be nice to have some debris raining down. And so we can actually isolate the vorticles that are swirling around and use that to spawn a bunch of points to add additional debris. Lastly, you also want to focus on a lot of high, small frequency details because that makes the explosion feel bigger. And so we might also look at a few techniques for adding just regular old particles to this whole mix. Anyway, we'll check out the next step in the next video.